Okay, so day 3A, we're going to look at it. It's a very, very complex identity that we can use here, but it is helpful in some ways, especially if you don't have a calculator on you or you don't have any sort of aid. You're strictly trying to do it by hand. This will help you. Of course, you have to memorize it. That's part of it. But sum and difference formulas for sine, cosine, and tangent. We're going to kind of prove one of them, and just so you see where it comes from. So our learning target here is just be able to use the sum and difference formulas for sine, cosine, and tangent. So angles U and V. So here's angle U is this big angle. Angle V is a smaller angle. Those are in standard position. And if we took U minus V, we'd get theta, which is this theta right here. So basically, this angle and this angle are the same. The chords of these two would be the same. So if I drew a straight line from here to here, so A to B, that would equal from C to D, from point C to point D, because they're the same angle. It's on the unit circle, so they would both have the same length. So starting with the idea that AB equals CD, we're going to use the distance formula. So think subtracting the x-coordinates, subtracting the y-coordinates. So if I took the cosine of V, that's its x-coordinate, minus the cosine of U, that's this one's x-coordinate. So that would be the difference. How far to the left is this? Plus, and then the sine of V would be the y-coordinate of this one. The sine of U is the y-coordinate of that one. If I subtract them in squared, then I'm finding how far up or down my distance is. When you're squaring them, you're doing Pythagorean theorem, and square root would be the hypotenuse, and making that a right triangle in there. Same thing over here. One of these points is 1 and 0. So that's why the 1, and so the cosine of 0 is this one's x, that's that one's x. Cosine theta minus 1, square it, plus, and then the sine is the y values. So sine minus 0, that's the distance or difference in the y's. Square it, take the square root, you're finding the distance from C to D. So if I do some simplifying here, and I'm going to pause and do some writing to save some time on the video so it doesn't take so long, but I'm going to actually square this guy, and I'm going to square that guy on the left side. Actually, first I'm going to square both sides. So both sides of the equation have a square root. So square both sides, that gets rid of the square root. So I'm going to put squared means the square roots are gone. So now it's just this, cosine V minus cosine U squared plus sine V minus sine U squared equals, and then all this squared. So no square roots anymore. Now I'm going to square both of these with an addition between them. So this is the first one squared plus, okay, equal. And on the right side, same thing, square this guy. And then plus, and this, since it's sine theta minus 0, that's just sine theta. Sine theta squared is sine squared theta. Now on the left side, kind of pair things up here. I got cosine squared V, sine plus sine squared V. That's going to be a 1. So I'll just put a 1 down here. And then cosine squared U and sine squared U, that's another 1. So plus 1. So those two are just going to be 1s. And then minus everything else. So minus 2 cosine V cosine U minus 2 sine V sine U. And then on the right side, kind of same idea here. I've got a cosine squared theta and sine squared theta, that's 1. Plus this one would be 2. And then minus 2 cosine theta. So 1 plus 1 is 2. I'm just going to change this to a 2 to save some space. And now if I have 2's on both sides, if I subtract 2 from both sides, those are gone. So really I can cancel those out. So I subtracted 2 from both sides. If I divide everything by negative 2, so divide everything by negative 2, I get cosine V cosine U minus sine V sine U, and that equals cosine theta. Okay, actually, and this one should be plus here too. I just caught that, so that should be a plus. And up above here, we said that theta equals U minus V. So I could actually take out this and say that equals cosine U minus V equals all of this. So notice when I'm subtracting, it's a plus. When I'm subtracting, it's a plus. And then if this was a plus in here, that means that would be a minus. So when it's a minus, this is joined with a plus. When it's a plus, this is joined with a minus. And then to help you kind of memorize these, and here's the other ones. I can use this exact same idea to prove these two also. I don't want to do that. Spend 5 more minutes of video doing that. But just notice on this one, when you're doing cosines, they're not the same. They're not the same signs, which I think of it as sine same, because notice here plus is plus, minus is minus. So sine is same signs. But with cosine, it's cosine, cosine, sine, sine. Here it's sine, cosine, cosine, sine. So when it's cosine, they're the same functions, but not the same signs. Whereas sine, same sign, but different functions. So sine, cosine, cosine, sine. And then, with the tangent, it's just kind of memorize that, whatever method you want to take. But just notice the signs are on top, it's the same, on bottom, it's different. If it's a plus, it's going to be plus minus. If it's minus, it's going to be minus plus. So use those guys. And now how we're going to do that is, I would love to just, because I can always use my reference angles. Okay, so I'm going to use reference angles. My reference angles are 30, 45, and 60. So if you need to, you can draw your triangles here. And it helps me to draw my triangles at least. So I'll draw a 30, 60, 90 triangle. And think of it the same way you do the unit circle. So the hypotenuse is 1. That means this would be a half and radical 3 over 2. And then for the 45, 45, 90, if this is 1, it's radical 2 over 2, radical 2 over 2. So that'll help me do my sine and cosine and all that good stuff. So if I'm doing cosine 15, that's not one of my reference angles, but could I write a sum or a difference that equals 15? So I could write cosine of 45 minus 30, because now that's the same thing as 15. And I could use my cosine difference identity here. This is my u, this is my v. I'm going to plug into this guy up here. So I'm going to do cosine 45, cosine 30. If it's minus, I go plus. And then it'll be sine 45, sine 30. So a lot of these answers will be coming out the same. If I'm always using these reference angles, we get a lot of the same kind of answers coming out. There's only so many combinations of answers because we're only going to be using reference angles. So cosine of 45, there's adjacent over hypotenuse, so that'd be radical 2 over 2. And then cosine 30, think here cosine is adjacent over hypotenuse, so that'd be radical 3 over 2. And then sine 45, radical 2 over 2. Sine 30, opposites over adjacent, so that'd be a half. We want to keep leave an exact simplest form. So when I multiply these together, multiply the tops, will be radical 6 over 4 plus radical 2 over 4. You could leave like that, or you could say 1/4 of radical 6 plus radical 2. But that's an exact answer. Type this in your calculator, then type in cosine 15, you get the exact same answer. Okay? So keep going here. So sine 75, the simplest way I think of it is 30 plus 45. So there's my u and my v, and I'm going to use this one. Okay, so it would be sine 30 cosine 45, plus is plus because with sine, same sign, and then cosine u, cosine 30, sine 45. So sine 45, you can either go back here and look at these guys, or you can look back at your reference. So sine 30, opposite over hypotenuse, cosine 45 is radical 2 over 2, cosine 30, radical 3 over 2, sine 45, radical 2 over 2. So it'll be radical 2 over 4 plus radical 6 over 4. Again, you could take out a fourth if you want. Think of that as radical 2 plus radical 6. Yeah. So it's actually the exact same answer. You know, those are the exact same thing. Okay, backside. And the trick is looking at these and thinking, what sort of reference angles can I use? So think back, we said our reference angles were 30, 45, and 60. Well, 30 is pi over 6. This would be pi over 3. This would be pi over 4. So then can I do a combination of this to get 7 pi over 12? If you need to, since it's over 12, put all these over 12. So this would be 2 pi over 12. This would be 3 pi over 12. This would be 4 pi over 12. That's 3 times, yeah, make sure I did that right. So what way could I use these to get 7 pi over 12? I could add these two together. So I do cosine of 3 pi over 12 plus 4 pi over 12, because that equals 7 pi over 12. Now for me, I just think it's easier, take these back to degrees. So 3 pi over 12 is 45, 4 pi over 12 is 60. So you're using those reference angles for cosine. Okay, so with cosine here, this is my u, that's my v. So it's going to be cosine u, so I'll put 3 pi over 12. I'm thinking 45 when I go to find that. Cosine 4 pi over 12. If that's plus, it's going to be minus. And then sine 3 pi over 12 times sine 4 pi over 12. Okay? And now when you plug these in, again, think 45, think 60, and those. So this would be, if you got your reference triangles, you can flip it over and use a front if you want, but this would be radical 2 over 2 times a half. And then sine, this would be sine 45, that's radical 2 over 2. And then sine 60 would be radical 3 over 2. So I simplify that. Again, radical 2 over 4 minus radical 6 over 4. Notice I've got radical 2's and radical 6's again, and I got 1/4 because I keep using the same reference angle, so it's coming out to be the same numbers, different order. I'm subtracting this time instead of adding, but yeah. And if you need to slow down, I went kind of fast there, but if you need to slow down, pause the video and try it out. Now we got tangent. We haven't used tangent yet, so remember your tangent from the front. I need to do two different numbers that whenever I add or subtract them, I get pi over 12. So there's a couple different routes you could take here. Yeah, because you could do 60 minus 45 or 45 minus 30. I should say 4 pi over 12 minus 3 pi over 12 or 3 pi minus 2 pi. Just pick one. I'll do these two. So I'll do tangent of 4 pi over 12 minus 3 pi over 12, which in the back of my mind I'm thinking is 60 minus 45. So when I'm looking at my reference triangles, I'm using 60 and 45. So this is my u and my v. So using your formula from the front, that'd be tangent 4 pi over 12 minus tangent 3 pi over 12. In fact, I might pause the video and write this in to save time, so you can pause the video and you write it in too. Okay, so now thinking tangent, look at your reference angles opposite over adjacent. Tangent of 4 pi over 12 would be radical 3. Tangent of 3 pi over 12, that's a 45, so opposite over adjacent would be a 1 because they're the same. Over 1 plus, see, tangent 45, again, that's radical 3 times 1, because you're just repeating these, so you can rewrite those in there. So now I've got, let's think of this. I think this is easier. We'll think of this as, well, nah, that's fine. We'll just go like this. We never want a radical on bottoms. We're going to use the conjugates. So I want to multiply by 1 minus radical 3 on top and bottom. So on top, when I multiply that all out, see, I get radical 3 minus 1 plus radical 3 over, this would be 1 minus 3. So on top I would have a right down here. So 2 radical 3 minus 4 over negative 2. If I divide everything by negative 2, that would give me a negative radical 3 plus 2, or you could say 2 minus radical 3 to put in, put the real number first, or the rational number first. Okay, I'll go a little bit faster now. The video's getting long, but on this one, it's the opposite. So like they plug the numbers in, and we're trying to figure out what are they trying to find. Now these aren't reference triangles, but if you look in there, sine, cosine, cosine, sine, that's sine. They must be using sine. And with sine, the signs match, so it's plus. And the two numbers, their u and their v, are 97 and 43. So this person must be trying to find sine 140. This one here, they're using cosines, so it's cosine, and since it's plus, that means we're doing a minus. Their u and their v is 72 and 130. So they must be finding the cosine of negative 58. If you look at it closely, you could flip the orders on this one, because maybe this was u and, if I flip this, maybe this, instead of being u and v, this was v and u. And it'd be the exact same formula. So instead, maybe they're trying to find what cosine of 130 minus 72 is. Well, that's 58. These have the exact same value, because with cosine, it doesn't matter if you're going up 58 degrees or down 58 degrees, how far right you go to get there is the same, so they're going to be the same value either way. This guy, they're doing sine, cosine, so that's sine. If it's minus, it's minus. Their u and their v is pi over 5 and 2 pi over 3. So that'd be, let's see, 15ths. So this would be sine of negative 7 pi over 15. This one here, only one formula looks like this. That's the tangent formula. The first one matches, the bottom one's the opposite, so it must have been a minus. Your u and your v are 140 and 60. So tangent 80 is what they're trying to find. Cosine, cosine, sine, sine, that means they're using cosine. It's a plus because that's a minus. And now my u and my v are pi over 6 and pi over 7. So if I go 40 seconds, this one's times 7, this one's times 6. So it would be cosine of 13 pi over 42. And the last guy here, that's obviously a tangent setup. So tangent, top one matches pi over 3, pi over 4. So that'd be tangent of 7 pi over 12 is what they're trying to find.